Hello, I'm starting a new series of videos, and this is on aldehydes and ketones, the reactions, and we're going to be doing synthesis and a lot of problems. But first, let's talk about what is aldehydes and what is ketone and do some nomenclature problems. So here you have what is different in aldehydes and ketones. Well, you have, in both, you have a carbonyl group, but in aldehydes, you will have an H here, and then ketones, you will have two R groups. That's it, methyl ethyl. So that is what identify an aldehyde. But typically, we draw it like that. We don't draw the hydrogens attached to a carbon. So when you do line structure, of course, you will do it if you were doing, for example, semi-condensed. You will do this, and this is showing now bonds to the atoms. So that's another aldehyde. 1, 2, 3, and 4, that is butanol. So the termination for aldehydes is Al. Al, that's your termination. Remember, your prefixes is for the number of carbons. In the case of ketone, the termination of that is O-N-E, so ketone. So let's go for a few examples. This is very easy. This is simply you in the aldehyde, because the aldehyde has that H, is always at the end or the beginning of the chain, so terminal. And you will always assign the number 1 to the carbon. So 1, 2, 3, and 4. You have 4 carbons, so your prefix is but, and it's butanol. So it's the same. Butanol. Okay. Now, here we have another molecule. Now we see that we have an R group and an R group. So that's a ketone, and our termination is going to be O-N-E. So you need to find out what is in case we have several chains, you find the longest chain that contain the functional group. The functional group is the ketone. And so here you have 1, 2, 3, 4, and 5. And whether you number from this side to that or the other way, you get the same numbers. Now we need to specify where is the functional group. So this is the prefix expand, but we're going to say there's 2 ways of saying. You can say 3-pentanone or pent 3-on. So these 2 names you can use. Now here's another ketone. In this case, I have, let's see, 1, 2, 3, 4, and 5. So same prefix. So it's pent. But now the functional group is in carbon 2. So you can say 2-pentanone. Or you can also say pent. Let me write it down. No, I'm going to erase that one on top. I don't want to touch the other structure. So what is the other name that we can give it? You can put that location, the locant, in the middle. So you can say pent 2-on. So either way is acceptable. Now notice that this 3 molecules, butanol, 3-pentanone, and 2-pentanone, are constitutional isomers. They share the same molecular formula, but even functional group is different. This is aldehyde and this is ketone. These 2, notice they are constitutional. The double bond, the carbonyl, is in a different location. So that's a good idea always to be reviewing that. Now let's look at the other molecules that we have down below. Here there's nothing, so it is an aldehyde. Remember that we don't draw hydrogens attached to carbon in line structure. This we draw because this is partially condensed. Okay, now, again, same strategy where you will count carbons. Now, but problem in this molecule is that you have 2 functional groups. You have here an alkene and you have an aldehyde. So when you have more than one functional group, you need to find what group has priority. And when you're choosing the chain, the highest priority group, functional group, is the one that is going to be determining that chain. Let's say here, what has higher priority? So say as a rule of thumb, the more oxidized the functional group, the higher the priority. For example, priority-wise, carboxylic acids have higher priority even than ester. But here I'm gonna just summarize. I'm gonna be here ketone, for example, or aldehyde, and there's several here, but I'm just going to include this for now. Alcohol are here, and these are greater priority than alkenes and alkynes. So, having said that, aldehydes has higher priority over the alkene. Because of that, I'm going to assign this the carbon number 1. So 1, 2, 3, 4, and 5. And again, I have 5 carbons. So my prefix is pent, and it is, if we didn't have the double bond, it will be pentanol. But I have a double bond here, so I need to E&E, remember that, E&E, all is the termination. So we're going to say pent for the number of carbons, 4 in pentanol, in all. Or you can say 4 pentanol. And I don't say the location of the aldehyde because simply the aldehyde, remember, is at the beginning or the end, however you want to see it, is terminal. So I don't need to put the location for the aldehyde, but it does have the highest priority. But I need to specify where the double bond starts. So it's a pentene for pentanol, or pent for enol. Okay, so let's look at the next molecule. Again, we have priorities here. We have 3 functional groups. We have here a ketone, an alcohol, and an alkene. And looking at my priorities, and again, remember, rule of thumb, more oxidized is higher priority. So ketone will have higher priority over the alcohol, and that is higher priority over the alkene. So I need to choose my number, and this is the longest chain. I don't have other chains conflicting with that. I can make another example to choose a main chain. Let's say I'm going to draw another molecule real quick here. In regards to the length of the chain. And let's add something here. I'm going to add a hydroxyl group. So in this molecule, I'm going to do that later. So here I have the ketone in the alcohol functional group. And again, I need to find priorities. The ketone has higher priority over the alcohol. Now I need to find the longest chain that contains that functional group. I'm going to add here one more. All right, so if I choose this chain, let's say here, 1, 2, 3, 4, 4, 5, 6, or I can do 1, 2, 3, 4, 5, 6, 7, 8. That's longer. So I need to choose, having said that the ketone is higher priority over the alcohol. And then this chain is not the longest. The longest will be one that contains the main functional group. So 1, 2, 3, 4, and I'm going down 5, 6, 7, and 8. So that's my parent chain. And it is 3, and it's a ketone. So 8 carbons, so it'll be 3 octanol. But that's not all. I have another functional group and I have substituents. I have an isopropyl in carbon 4 and I have a hydroxyl in carbon 5. So if I have an isopropyl and a hydroxyl, rules is that now you need to list alphabetically. So in the case of listing alphabetically, the prefix iso is the only prefix that we actually take into account when listing. If you had a third butyl or sec butyl, that you don't take into account the prefix, but the word but. But in the case of iso, you do. So when listing, I need to list iso here before hydroxy. So I am going to write the whole name here and it's same for isobutyl 5-hydroxyl 5-hydroxy, and then that continues over here. I don't have room, so 5-hydroxyl. The name continues here, 3-octanol, and I am not done because this is a chiral center. So to determine the priorities, priority 1 is your OH, so you need to review that. You can check, I have other videos about configuration. So here you have an H going in, fastest lowest priority. So the second priority is up here. So you are going to be doing 1, 2, and 3. So this is S. So preceding all of that, I need to say 5S, 4 isopropyl 5-hydroxy, 3-octanol. I'm going to continue doing the others in another video.